let's not do cotangent, let's do tangent. I don't even make it that difficult. Okay, a little bit more fun. This doesn't limit you to an interval, right? Right?
Exactly.
So let's see what we're going to do. What's the period of this function going to be?
There's no period. Oh, wait. Somehow.
Why you say pi? All right, the period of tangent t is what?
Pi.
Somebody said it.
Pi.
Tangent t is pi.
That's tangent t is pi. This is not tangent t.
So it's pi over 2.
All right, what does the 1/2 multiplied times the t do? To the period. What's that? Oops.
What?
It does whatever you think it's not going to do.
That's right.
Double it.
When you multiply times what's inside, okay, it does the opposite of what you think it would do. So rather than cut it in half, it doubles it. So what's the period of this function going to be?
2 pi.
2 pi. Let's do a table. Oops. Let's see what happens here. If I plug in 0, what's the tangent of 0? How do I get tangent?
Sine theta over cosine.
How do I get tangent? Never going to forget.
Sine over
Sine
cosine.
over cosine. So the tangent of 0 is the sine of 0 divided by the cosine of 0, which is just what? It's 0, because it's 0 over 1, right? So tangent of 0, 0 over 1, which is just 0. That tells me the point 0, 0 is on the graph. If I plug in pi over 2, that's the tangent of pi over what? What's 1/2 times pi over 2?
Pi over 4.
Pi over 4. What's the tangent of pi over 4?
1. Times.
Square root of 2 over 2 divided by the square root of 2 over 2, which is just 1, right? So that tells me the point pi over 2 1's on the graph. What if I plug in pi? What if I plug in pi? Pi times 1/2 is what? Pi over 2. What's the tangent of pi over 2? 1 over 0. What does that mean?
Sine.
There you go.
Vertical.
That's a vertical asymptote. Let's go back to the other. Oh no, let's go and do 3 pi over 2. 3 pi over 2. What's the tangent? 3 pi over 2. Oh no, tangent 3 pi over 2 times 1/2. What's 1/2 times 3 pi over 2? 3 pi over 4. What's the tangent of 3 pi over 4?
1.
Not a 1.
Or
It's
negative 1.
negative square root, or I'm sorry, square root 2 over 2 divided by negative square root 2 over 2, so it's negative 1. Okay? So that tells me this point's on the graph. What about tangent 2 pi? It's going to be 0. So point 2 pi 0 is on the graph. Okay. Do you see enough to generate the rest of this graph?
Yes.
Where can I go from here?
Negative pi over 2 will be negative 1.
Negative pi over 2, negative 1. What about pi? Negative pi?
That'll be a vertical
It'll be a
asymptote.
vertical asymptote. What did we say the period of this one's going to be?
There's,
It's going to be 2 pi, right? Now if you look at that, that's one cycle of the tangent curve. How far is it from negative pi to pi? That's 2 pi. That's one complete cycle. That's the period. So where am I going to go from here? What happens at 3 pi?
so
It's an asymptote, right? What happens at 5 pi over 2?
it's positive 1.
That'll be 1. What about going the other way? What happens at negative 3 pi over 2?
It's at positive 1.
It's going to be positive 1, because this cycle is just going to be over and over and over again, correct? Where would my next asymptote going to the left be? At negative 3 pi. With me on this? Once you get a little bit, especially once you get one period of this, the rest of the graph's easy. We sketched the graph, but we're not finished, are we?
Is this on the domain?
How do we do the domain on this one?
Domain is not X is right. Such that, what is it?
What is our variable here?
T.
So t such that t is what? Not equal to. Say it again. Yes, not equal to odd multiples of pi. How do I represent the odd multiples of pi?
No,
Two
Two minus
n
one.
minus 1.
2n minus 1 is odd number times pi. Those are the odd multiples of pi. What's the range?
Negative infinity to infinity.
What's the range?
All real
Negative infinity to infinity, all real numbers, whichever way you want to represent that, with the negative infinity to infinity or the big ugly R.
I'd rather, you know, you get a Sonic, there's like Cupid.
You can stop that.
They have the infinity stuff.
How about that? You can stop that.